Hey y'all, welcome back. I hope you're all well. Thanks for joining the channel again, and good to see you. Today on my bench I have a NAD 2100 power amplifier. What does that say? Monitor series power amplifier. The 2100 is power envelope. It was brought to me by a local gent who views the channel. Wants this repaired. He says one channel is out. I asked him if it was intermittent. He says no, it's just out. So we're gonna have a look at this. Chunk power switch, 2 speaker switches, and it's got input levels for left and right. Center detent there. Mono. I guess this amp's bridgeable. It's got protection soft clipping LEDs. And on the back we have input, which is normal and lab. This is an NAD thing they had on some of the other amplifiers, where you can switch between normal input and lab input. The normal input being it has an input filter, a low hertz filter, a low cutoff filter to get rid of rumble. It's bridgeable, and it looks like the switches in the off position right now, which is good. I'm assuming he tried it in both positions when he said that the soft clipping switch is turned off. And there's an impedance, 8 ohms high, 4 ohms low, and it's set to 4 ohms right now. So there's a few switches here for configuring, 2 outputs, 2 courtesy outlets. So let's pop the lid before we plug it in to try it out and have a look inside. If there's a blown channel or a channel not working, there could be some fuses that are gone, or maybe there's some other carnage inside we don't know about. Alright, screws are out. Let's take a look. Oh, it's like a liquid spill. That's a sticky mess. Some kind of syrupy stuff. Yeah, I don't see much going on here. Look at this thing. Half of it's empty. There's about 7 or 8 inches here of empty space. Wow. They could have used that to put another transformer. I don't see anything going on. I don't see anything burnt. But a little bit of dust in here. What I'm going to do is I'm going to take this outside and blow the dust out of it, because I can't even read the fuses because they're so dusty. But we'll have a look at this one. Clean it up first. Okay. Let's see what we got here. A big power transformer. This thing's huge. 2 10,000 microfarad caps at 80 volts. 2 10,000 microfarad caps at 50 volts. Each one has a bridge. A couple of relays. Everything else looks what's going on here? Alright, so I blowed the dust out of it, and it seems to be a little better now. Just giving these fuses a quick look. It doesn't look like any of them are blown. Just going to go through and test them. They're all intact so far. So there's 6 fuses here, and they're all good. So I'm really hesitant on plugging this thing in, because the spill happened around here in this area. Well, actually you can see it. I don't know if you can see it. It's all integrated into the heatsink here. I'm going to have to clean all this out. And it also spilt onto this circuit here. I don't know what this is, but if it's a high impedance, low signal, voltage signal, I'm sure anything that's syrupy or sugary will conduct electricity and short things out, or at least provide current paths that aren't expected to be there. So I might have to take out this main board and give it a wash, because it seems like it's in everywhere here. It's all over transistors and resistors, and yeah. I don't want to plug it in because I might do more damage here. But I'm going to keep poking around with my ohm meter just to make sure all these transistors are good and there's none that are shorted, and then we'll just start cleaning up and take it from there. Alright, so I pulled off the bottom cover, and bad news, yeah, the leak went right through to the bottom plate. You can see it here, and you can see it here. This is coming from the top of the printed circuit board down and around. So yeah, we got a problem with the spill here. So we're gonna have to clean this up. I'm gonna have to get underneath here and check out all of this area and clean it to the best I can, because well, that's not going to be good. Everything's sticky. You see that there? And it's the transistors. There's a lot of low-level signals here. So yeah, it's not good. Alright, so I'm sitting here scratching my head on what to do with this amplifier. I want to take... Well, here's the problem. This whole area here is coated, even down, you can't see it very good, but down here there's a little subboard for the input power, and there's sticky stuff all over that. That's not a problem, I can clean that. The problem is I want to remove this board so I can wash it, and I have to wash it because I can't just go pick parts off and clean underneath them. It's such a wide area. It actually extends from about here right up to here, and this whole area is all like got spooge on it. Now these relays are covered in it as well. I don't want to wash those. What I want to do is remove those from the board before I wash the board. Remove the relays, probably remove the trim pot, and I think the rest of the components can stay, except for there's a couple switches here. Probably remove these two switches because I don't want water getting into those. And then I can spray it down or do whatever I need to do to get this cleaned up, and then dry it, and then I can put those parts back on. But it's going to be a big job. Oh boy, oh boy. It's all in the wiring. All this wiring is all coated, and it's actually, well, it's not really into the transformer, but it's splashed onto the transformer here. And I don't want to get the transformer wet. That's why I want to remove the board, so I can work on the board independently. And I'm just looking at all the massive wiring looms here. It's just everything has to be disconnected to make this work. So I don't know. I'm gonna have to think about this. What I want to do, which direction I want to take this. For the most part, a lot of these things can be cleaned just the way they are here. This one's not bad. The speaker output's not bad. Some of these switches look alright, but it's all through here. Okay, I'll see what I can do. I think the main thing is just disconnect the transformer winding wires and leave everything else connected. I can remove a few of these wires just to make it a little more friendly. I'm going to pull up the service manual on this one, and then I'll see if it's got a wiring diagram. It saves me from drawing this all out and color coding everything. So since I got the board out, maybe you can have a good close look up at it. I don't know if you can see all that. It's kind of crystallized here, all in this area. You can see it's under the relays, and it's very sticky. I don't think it was spilled that long ago, to tell you the truth. All along under here too. These switches, a little bit there, because it seemed to flow along the edge of the board. But it's mainly right here when I'm going to wash all this out. So my idea is just get it under a tap with flowing hot water, and it's going to scrub it lightly with a toothbrush and get all these areas clean, and then we'll bring it back and we'll dry it. Okay, so we're back. It's all washed off. Looks pretty good. I think I got the majority of it. I could give it another scrub if I feel it's still not good enough. But it's my heat gun. I got this set to about 150 C, and I don't want to melt any plastics. I just want to heat things up pretty good. Once you heat things up, the water just evaporates like nothing. So you just put the heat on it. You go slow. And you start to see it dry up. I don't know if you can see that on the camera, but it just drives the water out. You can always flip it over and heat the bottom too, because this will help dry it out. The heat comes from the other side of the board. I'm going to take those relays apart, or open them up anyway, see if that sticky mess got inside. And if they did, I'll probably give them a trip into the ultrasonic cleaner, and then I'll dry them independently. But it looks like we could be okay. The bottoms are sealed. Looks like the bottoms are sealed. It's just that the tops are not. So I'll see how that goes. I could have made this go faster if I took a little compressed air and blew it off. Blew off the water first. But whatever, it's a little more time here. Okay, it's pretty much dry. Now what I want to do is I want to ESR all these capacitors just to make sure that they're okay. I have a feeling they're okay, but then I've said that before and it turned out to be bad. But I'll let this cool off, and then I'll give it a good look, and I'll give it another treatment with the heat gun just to make sure I drive off any traces of moisture that may be left, maybe sitting at the bottom of the leads. Capacitors, I don't think the moisture will affect them. I don't think it will wake up into the legs. Just want to make sure it's dry before we power it up. Alright, so I popped the tops off these two relays, had a look inside, and they're both good. Nothing got, well, it's not really true, but it did seep into the crack around where the lid fit, but there's nothing that got inside, so it's just a matter of wiping down the exterior. And I didn't think it would go inside. Well, you never know, because depending on how wet it was and for how long. But yeah, these ones had it on the bottom. Look at it, it's on the bottom too. This stuff, it seems pretty innocent when you have a liquid like this that's sticky and it's not really doing anything. But when you put current to it, it actually conducts electricity and becomes electrolytic, in that it can corrode and dissolve away your your contacts and your terminals and your pins. So yeah, you want to get rid of as much of it as you can. Ideally all of it. See, this one here is pretty gross. I'll have to get a little Q-tip and clean the inside rim before I snap the lid back on. Now if you really wanted to, you could replace these. You would have to just look up, there's a part number, it's 24 MB, 24 volt relay, and here's your pinout, your coils here. These two are common, and these two are normally open, so it's just a simple double pull single throw switch relay. And you can probably go on DigiKey and find one of these if you want to replace them. It's not really necessary though, if they're working. So let me clean this one up better. So I think everything's good. I still have to do the ESR checks, and then if all that passes and we're good there, and we don't need to change any capacitors, we're just going to start reassembling, and then we'll move on to testing. Okay, now we're hitting the home stretch here. I got the board finished. I got this part cleaned. Got all the components resoldered back in except for the input jacks, which I'll do after I connect some wires. There's some wires that go in behind here, and it makes it difficult with the jacks in the way. But everything's done. The pot's back in. I pulled these caps out, tested them. They're fine. I needed to clean a lot of that circuit glue was in behind here and here, so I cleaned it. I pulled these caps, cleaned that, and then put it back together. Everything looks looking good. Nothing to do on this side. I checked this side over for cracks, couldn't find any. So now it's a matter of putting it back together, getting the wiring all connected back, and we'll get down to some testing. So let's do that now. I'll spare you all the boring details here, but I don't expect there to be anything wrong with this amplifier. It had some liquid damage that probably caused it to one channel to malfunction. But we're gonna put it back together and see how it does. Okay, now that we've got things back together enough to where we can do some testing, first thing I want to do is I want to power it up and see how it performs. Now, the manual says that on power up, there shouldn't be more than 100 millivolts on either of the speaker output terminals, and that's with no load. So I removed my heatsink and load, and I'm going to power it up, and I'm going to check the DC offset on the output to make sure it's good. Beforehand, I did go through and I tested all of these semiconductors that are lined up along the back here and checked them for shorts, just to make sure that we don't have a channel out, because that was the original complaint, channel out. And I just wanted to make sure it wasn't because of a bad output device, and I don't want to smoke anything when I power it up again. So I got it powered up. No, I don't have it powered up yet. I'm going to power it up here. Right, toot sweet. Let's hook up a digital voltmeter to one of the channels. This is the left channel. Let's power this up and we'll see what we get. Now I know the voltmeter is not in frame, but I can read it here. It's reading negative 0.292 volts, even with no power. I don't know where that phantom voltage is coming from. Okay, let's turn this on. So let's turn the speaker on. And we are at negative 200 millivolts and dropping. Okay, shut off speaker one. Move these around. Turn on speaker one again. And we're getting about 130 millivolts on this one. Is that correct? Did I read that last one correct? Let me do that again. $160, $150, $140, and dropping like a rock. So it's stabilizing. $130, $125 millivolts. Okay, so I'm confident enough we can feed a signal through this thing and it won't damage my speakers. So I'm going to turn on the second set of speakers. I'm not getting a loud thumps out of the speakers. Okay, let's feed it with a signal. Yeah, select the right input would be nice. Okay, that's left. Right channel. Left channel. Seems I have a distortion in my left channel, but that could be my speakers. Right. There's an awful noise in there too. Okay. I'm getting a scratchy noise coming through, especially on the left channel. It seems to be intermittent. Okay. All right. We know both channels are working. Let's get a load on this and scope it and see if anything nasty is coming through the amplifier, or if it's generating its own noise, or what's going on here. So let's. All right. Before I go any farther, I want to do a bias adjustment on this because I don't want to do power test before a bias adjustment. So I have hooked up to one of the channels, and I'm not sure which one it is. I got my speakers turned off. I'll power this thing up. And we'll see, it's supposed to be 15 millivolts, and it looks like it's sitting around 22 and climbing a little bit. So we are a little bit out of adjustment. Let's set this back down to 15. And we'll let that settle, and then I'll check the other channel. Find the test points are right here. They got little pegs sticking up from the printed circuit board. And we got what do we got here? About 23. Let's turn this one down as well. And we'll let that settle as well. I'm going to give it about 10 minutes, and then I'll come back and I'll check that we're thermally stable and we have a stable bias. Okay, so we've been about 10 minutes turned on and everything's nice and stable. Nothing's getting hot. We are drawing about 21 watts from the outlet, and seems pretty low, or pretty good for amplifier of this stature. Nothing's overheating, so I'm pretty happy that we have a good solid runner here. Okay, so after I let it balance, it dropped quite a bit to 10, so I'm going to increase it back up to 15 again. I guess the original adjustment wasn't too far off, so I'm going to put it back up around 15. And this is after it's been warmed up for about 10 minutes. It's stabilized. and we'll leave it at 15, and check the other channel as well. Again, it has dropped, so let's put it back up again. Okay, so I think we're all set. I think next is to do some power tests, and we're gonna give me a minute to hook up the scope and get the picture-in-picture going, and then I'll come back in a second. You should be able to see the scope in the corner now. Okay, we have, let's turn the power on to speaker 1. And I believe we're feeding it a signal right now. Yes, we are feeding it a signal, so let's turn it up. Hang on a sec here. Let me get my probes adjusted properly. Yeah, this is... Okay. I'm going to keep increasing until we hit clipping. And we're hitting a clipping there. Starting the flat top. Okay, let me get a little bit. You see it's doing the soft clipping thing. Right about there, I think. 22.86 volts RMS on the output. Okay. Let's turn this down. Now that was with the soft clipping on. Let's try it with the soft clipping off, and we'll see what kind of a result we get with that. Okay, we're going to go back up again. Broke into clipping in, and there we go. Right about there. 23.76 volts RMS. So the amplifier is doing pretty good. I don't see any weird distortions. Okay, I'm going to reduce it to about that power level, and that is 22 volts RMS on the output. I'm going to let that cook for a while. I'm going to see how this does and make sure it doesn't overheat. This one transistor is getting hot. Same on the other channel. We're consuming from the outlet 216 watts, so a lot of that is going into heat, a lot of that's going into output. 50 watts a channel is the spec on this amplifier, I believe. Let me see, I might turn this down a bit. I just don't want to smoke anything. Turn this. Yeah, it's got an average rating of 50 watts per channel. Peak clipping power of 70 watts. Fairly good amplifier. I think I'm going to leave this at that, and let's do a little bit of frequency response test. Okay, so I got it set up on the signal generator. I can do sweep. So let's turn this on. I got it set from 10 hertz to 50 kilohertz over a 10-second period. Let's turn this on and get it running. And as you can see, the low frequencies are quite a bit more exaggerated. Right around, let's see here, right around 25. Right around that point there, 23, 25 kilohertz, it starts to drop. Not significant enough to be within that 3 dB, but it's doing pretty good. Seems the lower frequencies are emphasized. And I don't think I have anything. Let's try it with the other input. I'm just going to disconnect the input here and try it. I got it on normal input right now. I'm going to switch it to lab input. Okay, let's click it over. And we can see lab input is a lot flatter. It is practically flat. Little bit of a low dB boost on the low end, but yeah, it's a lot flatter. Okay, well that concludes this test. It's getting quite warm, and I have it on an output about 7 volts RMS, consuming 80 watts from the power. Let's turn this down. Yeah. Let's turn this off. Let's do that and let this cool. Now that it's shut off, we're consuming 29 watts, so it's still. Alright, so it's all back together, looking good. Everything looks pretty darn normal for this. A little bit of cleaning up, not much. Yeah, so it's just a liquid spill. I think it threw havoc into the input stage on the one channel. That's probably the reason why it wasn't working. So we're going to feed a little bit of music through this so you can listen to it. What do we have here? A little bit of The Damned. Stay at night, I've heard a refrain, it echoes your... Can't play this for very long because of copyright. You know that, and I know it, so... And I can't let it go. It's madness, I know. This feeling that dark passion has something to teach, but I never. Okay, that's all I'm going to do for that. All right, it's working good. I just want to say thanks for watching, and we'll see you on the next one. Oh, the person that brought me this NAD also brought me another NAD to work on at the same time. It's a receiver, it's a 712, so that's what's going to be coming up next. I just wanted to get this power amplifier out of the way, and then we'll let them know it's ready to go. So thanks for watching. Am I awake? Did I make a mistake?